Happy Friday.
Happy Friday, Andrew. How are you doing?
I'm doing well. How are you doing?
I'm doing pretty good. It's a little bit gloomy in New York, but it's lots of interesting things going on every day, so it keeps us busy.
Yeah. So, do you want to give a quick synopsis or reason why do we start Backprop? Why is it now the time we started a podcast? Would love to, for you to inform listeners on why we're starting this podcast.
Yeah, I mean, it started as a very simple thing of just us trying to record what we talk about all the time and just, see what happens and see where the conversation takes us. But there's a serious part to it, which is there's so much changing and so much innovation happening in AI. And it's, even for us being in the midst of it, really hard for us to keep up with what we should focus on. And so we kind of like the things that as a startup, we have to decide every day on what should we think about, how are things evolving over the next 3-6 months, a year from now, and how do we make decisions based on that. I think that's relevant to a lot of people because everybody's innovating and trying to build and integrate AI. And so hopefully some of our conversations will be helpful to others as well to glean from. So that's why we started Backprop.
Nice. And so maybe tell the audience a little bit about LastMile AI, as well as why we're starting this and what kind of experience we have. What has built that corpus of knowledge so that we can speak to it and hopefully provide a little bit of flavor as to what we're talking about that might differ from different posts out there or podcasts. And so I guess how do we start LastMile AI?
I mean, Andrew, you're familiar with it, but for the audience, I think the purpose of our company, the mission has been the same for the roughly 2 years we've been around, which is to enable software developers who may not be ML experts to build production-grade AI applications using generative AI. And there's a lot there because, how do you evaluate these applications and how do you measure the performance of these models? How do you control these systems now that they're getting more and more advanced and semi-autonomous? There's a lot there to constrain, to figure out, to decide. And our job is to build a developer platform that lets people do that in a systematic way. And you and I both worked at Facebook. We have been building AI tools for a number of years. And we've seen how tectonic the shift has been, even between predictive ML and generative AI. And kind of the people who are building these applications is a whole new, larger group of people. And enterprises are, for the first time, some of them being able to actually deploy AI systems and try to derive value from it. And there are a lot of question marks that we've also talked about on how much is the ROI? When do we actually start seeing results? Everybody's in that path where they're trying to get to production. Some applications have reached it, but it's still, fairly, you're on the bleeding edge right now if you're developing with Gen AI. And we want to make it more normalized. I think that's the mission of Last Mile. It's that last mile of problems that come with productionizing these systems that we want to help customers kind of traverse and resolve.
It's an exhausting last mile, I think. that 80-20 rule. You do 80% or you get 80% there, and the last 20% is about 80% of the effort. To be honest, it almost feels like a 95-5% rule. That last 5% is grueling.
It is grueling. And also everything is changing so fast. So, you decide on one direction today, whether it's your architecture or services you've set up, and 6 months later you have to make a decision. Is that still, state of the art? Is that still relevant? Is that going to scale further? And I think one of the things around that everybody's really trying to figure out is how do I even evaluate these systems? And how do I measure the performance of my AI applications? And so I wanted to talk a little bit about that today, because that's top of mind for a lot of people. It's top of mind for us. And maybe just start out with helping people understand what is AI evaluation. What do people mean when they talk about evals?
So the quickest, equivalent for evaluations is testing, which is if you get an output, the base case, an output from a large language model, how do you know it's right or it's wrong? When you go back to software development, you can run different checks on whether the code runs, compiles properly, builds properly, whether the execution's right, whether the function output passed unit test. What is that equivalent for ML and a little bit harder, generative AI? When you look at ML, a lot of people would start thinking, what does it look like to test something that is not just the code, but also the data that's going through it, as well as what it was trained on, which is why evaluations played a role within that field, batch evaluations, online experimentation, online evaluations, all of that. Generative AI made it way more difficult, probably 10x more difficult, because a lot of the tests that were run for traditional ML systems now needed to somehow represent a way of evaluating the quality of a result when it's very subjective, right? And so, disregard the LLM. If I were to ask, you or someone else to write a paragraph, how do you actually know, right? And in a standard grading system in the US, you have an essay or a paragraph that's a 90% and another one that might be 88%. What was that 2% difference, right? How did the teacher know that this is a slightly worse or slightly better paragraph? And that becomes extremely difficult with LLMs, where that grading criteria is not as rigid as what it was. And so this is kind of the open problem, and the problem why so many companies have a hard time productionizing these applications, because grading on whether it's right or wrong is extremely difficult to measure. And so when we look at a lot of the applications that are out there today, right, the ones that made it into production, they are things that can have this tolerance for error, right? So like, help me write an email, summarize this document for me, help me write a sales reach out. Human in the loop,
perhaps.
Yeah, human in the loop. Someone's revising it, or the quality doesn't need to be perfect, right? It doesn't even need to be close to perfect. It just needs something to get started with. That's great, but a lot of the value out there in the world and what people are really interested in is not that. They want the perfect, the thing that can actually yield value is get perfect. And this is where LLM evaluations kick in, and then it goes a little bit further, where now you have evaluations for the applications for the LLMs, right? So you and I talk about agentic systems, chatbot evaluations for code gen, evaluations for just LLM outputs. There's so many variations, right? Like you can't have, how you grade a good software engineer in their code will drastically differ from how you grade a customer support agent who's working on, resolving a customer issue. And so evaluations has been getting more complex over time. And
it's not just the LLM anymore, right? Like these are compound AI systems, and so there are multiple steps involved. So it's not just did the LLM generate a good summary, it's like, how did data come into the system? Was that the right data to be used for that kind of original objective? Right. And then how did it get transformed? How did the LLM respond? Like all of these steps need to you need to figure out where things went wrong, if they went wrong, and what does even right and wrong mean, which is, to your point, like really hard.
So it started off with, your LLM and RAG system, right? And your RAG system is essentially how do you get this additional context, retrieve the closest and most relevant context, and then feed into the LLM. And within that case, all of those metrics that came out, which includes metrics that we support, which is your faithfulness, which is hallucination detection. You have your relevancy, semantic similarity, correctness, toxicity, summarization scores. And then as the world evolved to have more agentic workflows, now it's more on these agent interactions, how do you evaluate it? And then the other one that's also coming up is reasoning, right? How do you actually know if an LLM did the proper reasoning for either the orchestration of agents or even just a reasoning task in general? And so it seems like, as evaluations are evolving, it's on a parallel flow to how generative AI is evolving, with each new use case and large domain and unlocks, there's a parallel side of evals that need to be there.
Right.
And I like to quote, Greg from OpenAI, where oftentimes evals is what you need to make progress. Yeah. So I guess one question for you is, why is eval so important? Why can't you just not use evals?
Well, it's a counterfactual in some ways, because why can't you just ship software without writing tests?
Yeah.
There are reasons that we do that, where it helps us. It's not just about like a one-off thing where you're saying, does my system work, and these kind of like use cases that I'm trying out before shipping it. It's also about keeping the system alive and well over a course of time. And it's even harder with the generative AI, because it's so closely tied to your data now. So these AI applications will invariably have concept drift that happens over time, or data drift as new data flows through the system, or as use cases evolve, how users interact with these systems changes. And so all of that means, unless you know what's going on and can really deeply understand how your application is responding in certain conditions, it's impossible to make changes. So how do you decide, if a PR goes in, whether it's doing a good job or a bad job at changing the system? And so it can be the simplest thing, like a lot of customers, as new LLMs are coming out, are experimenting with like, 4.0 mini came out, so let me see if I can replace 4.0 with 4.0 mini, or now 0.3 mini came out, so let's try like reasoning tasks with that. DeepSeek came out, so like people are experimenting with just switching the model. But think of how hard just that aspect is, of like, it's so easy to like switch the model ID and get a new model, but is it working better? Is it working worse? And that's just a small piece of your wider AI application. So not having evals is just gonna, you're shooting in the dark in that way. And so I do agree, evals is often all you need, because you can then make systematic improvements and progress and identify bottlenecks in your system. But I'm also curious, like, what are the most important kind of things to evaluate? How does someone who doesn't have any evals at the moment kind of get started, and when is the right time to get started?
Before I answer that, I wanted to just touch upon that data drift. Because I was talking with a friend, and I was telling him that this concept drift, data drift, we talk about it a lot, but working on these problems at Airbnb and Facebook, you wouldn't see it that often. It's the classic example is you build a model for let's say for recommendation or ranking, and you have summer clothes and now it's winter clothes. Like, how do you capture that nuance? And most of those models now capture it pretty well, and so it doesn't happen that often. And then the case that came up for LLMs and why it happens is so interesting, which is if you asked GPT-4o to write you the code for calling GPT-4o, it will actually get it wrong, because they released 1.0 in their Python SDK, which is a new way to invoke it, but all their training data was on before 1.0. And it's such a fascinating thing with these LLMs now, that concept drift and data drift is such a big issue. Right? So what if you release a breaking change on SDK? Does that mean that all the code gen for everybody else who's working on these systems will break because the new libraries will not work, right? You can only pin it on the version and just hope for the best long term. And if that library has some incompatible change with newer service updates, then it will break at some point. And so it's fascinating that concept drift and data drift is such a core part, which is how do you make sure that these models are trained on data from way back in time, the entire corpus of the internet, can actually reflect new things better. And that's really interesting. So sorry to derail, but to get back into your point of, if you're just getting started with evals, what metrics do you need? Where do you get started? When you're just getting started with evals, the first thing that we recommend is have a kind of a handful of ground truth data. And your ground truth data is what is right and what's wrong for your system. That handful of ground truth data is how you can test and figure out whether your system is working well or not. Now, just because you have the right data, it's difficult, right? So let's say I have the best paragraph possible written,
Yeah.
and then I have one generated from an LLM. How do I actually know, right, if it fits? And the metric you can use is, we recommend to start off with, one is you can do correctness, right? How close in correctness is the output from the LLM to the ideal answer? Then you can also do semantic similarity. How close is the output to the ideal answer? And then relevancy is a good one as well, making sure that it is relevant to the input question. And then you have a few, what we like to call, health metrics. Make sure that the output is not toxic, and make sure the input's also not toxic. And this is kind of your starting ground. Next step that we recommend, and this is a unique characteristic of our platform, is with that little bit of data that you have, if you can spare a few samples, you can actually fine tune to create your own metric for what you care about, because it's learnable. And we see this with our customers, which is, if you go to someone and say, what percent of faithfulness and correctness as well as relevancy, what's the composition like for whether it's right or wrong? A lot of people don't know. Actually, I don't know. Nobody really knows, right? It's all kind of a guess, but you can actually get much more systematic with it if you're able to fine tune your own metrics so that it cares about what you care about. And so that's how you kind of evolve from your built-in metrics, your default ones that are out there today, to eventually crafting your own, which is more representative of what you care about. And I'm curious, is there any additional metric you'd add on there?
Well, I think the meta point of what you described, I think, is it is very subjective in terms of what matters for either what part of the application you're evaluating. Like in some cases, maybe you do care about hallucination, so you want faithfulness. If some data went through an LLM generation step, you want to make sure that the output is still faithful to the source of truth data that you provided it. So it's context dependent on where these metrics are being hooked up. But then the other thing that you mentioned that's really critical is, in a lot of cases, it's really hard to even define or quantify what your success or about, like, what's a good response to you mean. You can encode some of those rules, but it's really, really hard to think about it. But it's easy to see it when you see it, like to know it when you see it. So you can say, oh yeah, that's a good response, and that's a bad response. And I think people can instinctively do that, especially developers building who are like really deeply in tune with their application. And so that's what, like, I think the approach we've taken is, you start by having some data set of sample data of your application, and you start just labeling like 1 or 0, is this a good interaction or a bad interaction? And then we can teach a model that those labels, and it can learn that in like through numbers instead of through words, which is pretty interesting. I think I don't think that's been explored as much before elsewhere, and I do think at least from our customers, we've seen that as a very worthy way of kind of encoding your rules without having to explain yourself, so to speak. But I'm curious, I guess, what do you see as the future of evals? Because there are a lot of nuance there as well. And you kind of mentioned earlier about reasoning and agentic workflows. How do you see evals evolving to accommodate these new innovations?
Yeah, a really good question. I think, so there's a few things which seem like more sound bets. The first one is, evaluations is a continuous process. So any system that has a one and done evaluation feels like it won't adjust with the times, it won't adjust with data drift, or people's perspectives of what's right and wrong steadily change over time. And we've explored the ideas of active learning, making sure that this fine-tuning of a metric will change over time and adjust. And that's a really beautiful concept, because similar to how the model providers like OpenAI, Anthropic are continuously making improvements, you can have evals also improve while it's improving, so that you have a better system over time. And that's a real kind of beautiful thing, that that as things get better, that your application is always moving towards a state that you really care about. The second thing I wanted to mention was, the future of evals. one part of that is the debate of LM as a judge versus using a more classical NLP style or kind of an encoder style model. And I think the jury is still out. LM as a judge has amazing capabilities for reasoning and complexity of task where it can be many different things, but it won't give you precision, right? So you'll get a number from 1 through 5. It's great.
If at that.
Yeah, if at that. And that's really hard to decide a business when there's a 20% margin of error, right? So what's the difference between 3.2 versus 3.3, right? And some might folks, well, law of large numbers, if you run enough, rows against it, then you'll have much more precision. But even then, you're still having quite a large margin of error. And, when we run through benchmarks like how you eval, we can see that, for 20% of the cases, it can't really tell the difference between a hallucinant answer and a real answer. Yeah. But how do you solve reasoning tasks? Yeah. How do you solve these, tasks that require additional logic where LMs really excel at? And then the other side of it is using encoder style models, which are faster, more precise, but cannot get the wide array of complexity that exists in the real world, right? Yeah. Which is like a lot of interdependencies of this answer is only right once I combine multiple pieces of logic together, right? And so it seems like both have a role to play in evaluations over time. And so the future, I think, is some combination of the best of an LLM, the best of these encoder style models, both improving over time, and maybe another one as well that will be introduced at some point in time to evaluate specifically agentic systems or evaluate the actual execution plan of which agents do I call and how do you validate that. And so that seems like the future. I'm curious to see specifically for agentic systems, what have you seen for evaluation?
Yeah, I think it's, agentic systems are basically a microcosm of multi-step workflows. Yeah. And so the most important thing is breaking down that workflow, not just evaluating the end-to-end, like input came in, output went out, because there's so many steps involved, and some of them may actually be semi-autonomous, right? Depending on how much agency you give the agent. Yeah. And so then depending on what the kind of task is, for example, an agent may generate code and then execute it in a sandbox environment. Yeah. So then you want to evaluate the quality of the code it generated, but also evaluate it against what the original task was, and is that relevant to the original task. Yeah. If it's making tool calls, you want to evaluate, is this the right tool to call at this step in the workflow? Did it construct the tool call in the right way? Did this tool call succeed or fail? Yeah. So like those are, so every step needs to be broken down into intermediate pieces. You mentioned routing. That's a very common thing where, for example, even in a Q&A system, you have an input come in and you want to identify intent and then based on that route it to the right kind of step in the workflow. And so did it route correctly? And so if you really break down the system into these intermediate steps, then you can have a high confidence because you are able to say, okay, routing is like 87% accurate in aggregate, or tool call quality is like 95%. And then you can really identify where the bottlenecks are. And then you can also optimize the whole system end to end that way. So for example, you could say which models are being used and where's the cost, because in agentic systems, cost and latency is a big thing. Because you're calling multiple things in a loop. And so in that case, you could find the bottlenecks on cost and latency and then swap out for cheaper models, or maybe you don't need a super intelligent model in one step of the workflow. And so just being able to break down the problem into more manageable, achievable kind of steps really helps get somewhere. And so that's something top of mind for us, I think. We're really trying to focus on that.
So breaking down that, it sounds like there are agents where you're validating the input and output, right? Yeah. The unit test of an agent. And then you're also validating the orchestrator, right? Of did the routing happen properly? Right. And based off of where I'm in this kind of execution graph, what the input and output was that the right decision for
Right.
whether that was the right one to call?
Exactly.
And oftentimes what we talk about is evaluator, router. When you look at them, they kind of look similar. It's like if you're grading the grader with, also doing a classification, you're starting to figure out like, okay, well, it's like, can that just be the router?
Yeah.
Which is where they're kind of two sides of the same coin.
I want to poke a little bit further there,
Yeah.
actually. So, like, do you think of evals as classification tasks in general? Like, can you apply evaluator models to non-evaluation tasks?
Yes, for sure. It's, I think evaluators, as they're doing classification tasks, and whether they're used for grading an LLM or whether the LLM is doing any classification task that shouldn't be using an LLM, they're one and the same. And I think having both has some synergy where, as long they're not the same model architecture, so you can kind of, whether the classification task runs and use an LLM to grade or you go vice versa, has a little bit of redundancy built in, which is nice. And so that offers a nice opportunity, yeah. But then you're grading the orchestrator on like, is it routing properly? And then you're also doing kind of a large scale grading of the entire execution that ran, was it right or wrong?
Did the objective get satisfied?
Yeah. And I'm curious, can you use evaluations to optimize that graph? You mentioned that like cost is an issue, latency an issue, but if you have this full execution graph, we've worked on different graph-like systems and you have the full execution graph, you can always put it in to optimize it further.
Yeah.
What does that look like, and how does evaluation play a role there?
I mean, there's a concrete example of this. There's a framework called DSPy, which does this for prompt optimization by taking an evaluation first perspective, right? Like you define what are the success criteria, what's the optimization function, and then you can kind of optimize prompts in a systematic way. And now you can what's really cool is you can extend that to the whole system and really and there are all sorts of like traditional ML techniques like hyperparameter search and other things that you could leverage or at least be inspired from to do almost automatic optimization. But at the very least, I think like baby steps, right? You can at the very least say these are the parts of the system that are causing bottlenecks, whether that's performance, latency, cost, hallucinations, and then at least you know where to focus. And then the next set of once you fix that, then you can iterate further and find the next set of things. But I think long term, you're absolutely right. If you can really set up evals in the right way, then you can have automated kind of optimization workflows. And you mentioned the evaluators are constantly improving, your application is constantly improving, building that virtuous cycle into a workflow. That's the dream. Right? And so
it kind of I kind of led you in there, but the thing that it ties all back to is build, and test, or build and evaluate is one cycle, one workflow. And the more you improve on one without improving the other, you're going to see that workflow kind of break down.
Absolutely.
And so you kind of need an equal investment on the build and the test or evaluation side to create that harmonious cycle. The dream being that it can all be automated, but in that DevOps cycle, you have the circle of build test until you have production grade system. And so with that, it's a beautiful way that agentic systems, RAG systems,
future systems
that evaluation will constantly play a role, and it will help create this harmonious loop of development.
Well, I love that as a parting thought.
Amazing. We recently launched an ebook that for people who are just getting into evaluation and want to learn what is evaluation, why is it important, how to think about it as best practices. We've launched it recently. And so please sign up and we'll send you the free ebook and you can get started from there.
Amazing.
Thank you for joining us on this podcast.
Bye.